Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of probability theory. This is the previous examination question. So the given example is if two events capital A and capital B are independent, show that first bit is A bar and B bar are independent events. Show that A bar and B are independent events and show that A and B bar are independent events. This is a previous examination question. So now coming to the solution, first bit solution. So the two events capital A and capital B are said to be mutually independent events if it satisfies the condition probability of A intersection B is equal probability of A into probability of B. See, two events are mutually independent event, statistically independent event. The probability of A intersection B is equal to product of their probabilities. So this is the standard condition. So we know that probability of A bar is equal to 1 minus probability of A. So the probability of success and probability of failure is equal to always 1. So that is probability of A plus probability of A bar is equal to 1. So from that expression, probability of A bar is equal to 1 minus probability of A. Now here first bit, A bar and B bar are the independent events. You can prove that. You can prove A bar and B bar are independent events. So consider, we know that. So using De Morgan's law, the complement of union of two events is equal to intersection of their complements. So that is A union B whole bar is equal to A bar intersection B bar. So in this equation, take the probability on both sides. Probability of LHS term is equal to probability of RHS term. But we know that probability of A bar is equal to 1 minus probability of A bar. Using this expression, this probability of A union B whole bar is written as 1 minus probability of A union B. So using addition theorem or the joint probability theorem, this probability of A union B is probability of A plus probability of B minus probability of A intersection B. So multiplying this within the bracket term minus, we have 1 minus probability of A minus probability of B minus into minus plus. So minus into minus plus probability of A into probability of B. Okay. Now we are the probability of A intersection B. So events A and B are independent events. Probability of A intersection B is probability of A into probability of B. Now we are the applying that condition. And on RHS side of the equation is arranged as 1 minus probability of B into, in this term and in this term, take the common minus probability of A into 1 minus probability of B. And RHS side of this equation, for both the terms, 1 minus probability of B is the common term. Therefore, 1 minus probability of B into 1 minus probability of A. So using this condition, 1 minus probability of A is probability of A bar. Similarly, 1 minus probability of B is probability of B bar. So therefore, probability of A bar intersection B bar is equal probability of A bar into probability of B bar. Hence, the events A bar and B bar are independent events. Next, second bit solution. So we know that probability of A bar intersection B plus probability of A intersection B is equal to probability of B. So in this equation, this term is going to the RHS side. We have probability of A bar intersection B is equal probability of B minus probability of A intersection B. So events A and B are independent events. Probability of A intersection B is probability of A into probability of B. Okay, on RHS side, take the common probability of the B. So probability of B into 1 minus probability of A. So but we know that 1 minus probability of A is probability of A bar. So therefore, events A bar and B are independent event. Probability of A bar intersection B is equal probability of A bar into probability of B. Hence, from this equation, we can conclude that A bar and B are independent events. This is the second bit solution. Next, coming to the third bit solution. So we know that Probability of A intersection B bar plus probability of A intersection B is probability of A. So this term is going to the RHS side. We have probability of A intersection B bar is equal probability of A minus probability of A intersection B. A and B are independent event. Probability of A intersection B is probability of A into probability of B. On RHS side, take the common probability of A. We have probability of A into 1 minus probability of B. 1 minus probability of B is probability of B bar. So from this equation, we can conclude that the events A and B bar are independent events. So from all these three bits, finally we concluded that events A and B are independent events. Events A and B are independent events. A bar and B bar are also independent. A bar and B are also independent events. And A and B bar are also independent events when A and B are independent events.